let's start with the simulation. We're using Livewire Professional Vision software, and it basically works as follows. First of all, let's take a look of the 2-byte register. Actually, 1 byte for register X and another byte for register Y. We are using these two devices, they are the same, but just to watch what is happening in each register. So XLA1 is for register X and XLA2 is for register Y. It's a logic display, so we can watch or see only zeros or ones. And I'm using these graphs that represent register X and register Y to look at the logic states. And I'm using a 1 Hz clock to make the work easier. And I connected the Q prime output of the last register, well, of the last flip-flop of register Y, just to make a kind of feedback with the first flip-flop or the more significant bit of register X. First of all of the flip-flops have a initial state of 1. So if all Q's are 1, then Q prime, well, it is 0, right? So at the beginning we are getting a 0 in the input of or more significant bit of register X. Then, since all of them are 1s, we are going to be changing each one by a 0 in order, right? So this is the first one, second one, and so on. Just simulate that, and let's see. Channel 9 is the clock of 1 Hz clock, and channel 8 and channel 0 are the same. So this is the more significant bit of X register, and this is the less significant bit of X register. The same here, as both are the same. We are getting here that channel 1 is the more significant bit of register Y, and channel 8 is the less one. Just to mention that this pattern, this changing, just occurs when our clock has a high state. So when it gets a right stage, we're going to change the state of our flip-flop. And that's it. Thank you for watching.